All right, H. So I'm gonna just try plugging in -2 direct sub to see what happens, to see if it actually works out. I'm just gonna do the work on the side, and when I try plugging it in, I get 2 times -2 plus 5 minus 1 over -2 plus 2. I already know it's not in the domain because of the denominator, but I end up getting square root of 1 minus 1 over -2 plus 2, which is 0 over 0. So I know there is some kind of hole here, and so that means I gotta use some algebraic strategy to rearrange this expression. And the strategy we're going to use is rationalization. So why don't we do our work on the side here? So if I have 2x plus 5 minus 1 over x plus 2. To do rationalization, I need to multiply by this on the top and bottom. I'm going to multiply by, I'm going to keep the radical expression, and I'm going to change this. And then I'm going to keep the number, but I'm going to change the sign. Okay, so basically what I did is I took this right here, this the expression with the radical in it. I copy pasted essentially the same thing, except the one thing I want to change is this sign right here for the number. Okay, so when I do that, what ends up happening, and I'll do some work here on the side, I'm going to multiply the top using the area model. 2x plus 5 minus 1, 2x plus 5 plus 1. I know when I multiply my radicals together, it gets rid of the radical sign. This becomes negative root 2x plus 5. This just stays the same because I'm multiplying by 1, and 1 times -1 is -1. I see that these two are opposite signs, so they cancel out, and then when I rewrite this expression, it becomes 2x plus 5 minus 1, and it ends up becoming 2x plus 4. Okay, sweet. So what I did is I turned the top expression into 2x plus 4, and what's really important is we need to keep the bottom expression and not multiply it out, and you'll see in just a sec. I'm gonna go one step further, because that 2x plus 4 I can factor out of 2 and get to x plus 2. Okay, so now you see that we can cancel or create a 1 out of these guys, which leaves me to change the form into 2 over square root of 2x plus 5 plus 1. Okay, so this, I did all this side work here to help me change this expression into this expression. Okay, so now I'm gonna say this is equal to the limit as x approaches -2 of 2 over square root of 2x plus 5 plus 1. And now let me try direct substitution. 2 over square root of 2 times -2 plus 5 plus 1. And that ends up becoming 2 over the square root of 1 plus 1 is 2, so 2 over 2, and the answer ends up becoming 1. Sweet deal. Okay, let's do I. It looks like another rationalization problem, and I can see that if I try plugging in 1, that becomes 1 minus 1 and ends up becoming 0. If I plug 1 in here, I end up getting 1 minus, and the whole inside becomes 1, 2 minus 1, it ends up becoming 1 as well. So if I try direct substitution, it ends up becoming 0 over 0. So I know I'm going to have to use algebra again, rationalization. I'm going to do my work on the side here and try to change my form. So rewrite this expression, 2x squared minus 1 over x minus 1. Alright, so we're going to multiply by the same expression top and bottom. Now, like the previous problem, what I want to do is I want to take my expression that has a radical in it. I want to keep the same expression and numbers, okay? But here's the trick. A lot of people are going to want to change this sign in between, which is totally fine, but you have to be very careful with your algebra. And so what I'm going to suggest is actually keep that sign, but change this sign. Oh, sorry, I change this sign here because technically this is a positive right now, so I'm going to change that to a negative. Okay, now why is that? It seems new, but it's actually the same. If you look at the problem right above, notice what happened here. We changed the sign of the number. You see that? So look at down here in problem I. I'm changing the sign of the number, not the radical. Okay, so it's the same idea. So that's my suggestion. And then x minus 1. Or sorry, I gotta copy. And what's cool is I can just go like this, copy, and then paste. And then now I have the same thing on the top and bottom. Okay, so sweet. So I got that. I'll just erase the highlight parts now. And I'm gonna rewrite this, but first I should probably use the area model to help me multiply out. I have a 1 and a negative root 2x squared minus 1, and then I have a negative 1 and a minus square root of 2x squared minus 1. Negative 1 times 1 is negative 1. Negative of a negative square root is a positive square root 2x squared minus 1. 1 times negative 2x squared is itself. And negative times negative is a positive, and we get rid of the square root, so it becomes 2x squared minus 1. We can see that there are opposite signs there, cancel those out, and then when we put it all together, it's 2x squared minus 1 becoming 2x squared minus 2. So this whole top part turned into 2x squared minus 2 all over x minus 1. Now remember, we don't want to multiply the bottom out, because we want to end up canceling terms. So I'll factor the top, factor out of 2, I get x squared minus 1. I see that we still can't cancel, but I can factor one more time on the top and get x minus 1 and x plus 1. Ooh. And finally, we can create a 1 or cancel that guy and get 2 times x plus 1 over negative 1 minus square root of 2x squared minus 1. So we finally changed the form into this lovely form here, and then let's see if we can use algebra and direct substitute that. So I'm going to rewrite this problem now. You wrote it into this form. Okay, so when we try direct substitution, I get 2 times 1 plus 1 over negative 1 minus square root of 2 times 1 squared minus 1. And at the top I have 2 times 2, and at the bottom I have negative 1 minus square root of 1, which is just 1. So it ends up becoming 4 over negative 1 minus 1, which is negative 2. And so the answer becomes negative 2. Fantastic.